Okay, in our last section, we talked about the different rules of probability. So we're going to dive into a specific rule called the addition rule, and then we're going to talk about complements at the end. So here we go. Use the addition rule for disjoint events is what we're going to study first, then the general addition rule, and then we're going to find the complements. So a Venn diagram, remember these from grade school, provides a useful way to visualize probabilities. Remember, the entire rectangle is your sample space, and each circle represents an event. So the entire rectangle is your sample space, so every time you have that, you have to put everything in there. All right. Venn diagram below, the sample space is 0 through 9. See, every number is accounted for. 0, 1, 2, 8, 9, 3, 4, 5, 6, and 7. So they're all included in the sample space. Event E is 0, 1, and 2. Event F is 8 and 9. So look, 3, 4, 5, 6, and 7 are not in either of the two circles. They are, however, part of the sample space, so they are listed up at the top. They could be anywhere on the square as long as they're there. Okay, two events are disjoint if they do not have any outcomes in common. So another name for that is mutually exclusive. Mutually exclusive and disjoint are the same thing. Okay, two events are disjoint if it is impossible for both to happen at the same time. So E and F are disjoint. I can't have a number in E and a number in F at the same time because the numbers don't overlap in any way. Other things you can think of. You can roll a die and pull a name from a bag. You could, another set of disjoints would be juniors and seniors. Juniors is one set, seniors are another set. They're not going to overlap because you can't be a junior-senior. You're either a junior or you're a senior. Okay, just an idea of what disjoint or mutually exclusive. They interchange these two terms, so make sure you know those. Okay, for disjoint events, the outcome of E or F, think about geometry for a second, or means only one has to be true, can be listed as the outcomes of E followed by the outcomes of F. Since there's no duplication, it's just a list. And so that leads us to the addition rule. The addition rule says that the probability of E or F is the probability of E plus the probability of F. So we can find the probability of E or F if we know both of those probabilities. It's also true for more than two, so E, F, and G. Okay, and just, again, add them together. They have nothing in common, so they're not going to overlap, so we don't have to worry about that. We just add the probabilities together. For example, roll a fair die. What is the chance of rolling a 2 or lower or a 6? Okay, probability of a 2 or lower is 2 out of 6, a 1 or a 2. Probability of a 6 is 1 out of 6. They're not connected in any way, so 2 out of 6 plus 1 out of 6 is 3 out of 6, or 1/2. Okay, general addition rule, you've already seen it pretty much. The addition rule only applies to events that are disjoint or mutually exclusive. Again, that term is mutually exclusive. Okay, if two events are not disjoint, this rule must be modified. We'll talk about that in the next section. Some outcomes could be double counted, so we'll talk about that one later. The Venn diagram illustrates how the outcomes 1 and 3 are counted both in event E and F. So the circles are overlapping. So E and F are overlapping, and 1 and 3 are in both groups. Okay, rolling a fair die. What is the chance of rolling a 2 or lower or an even number? So the probability of a 2 or lower is 2 out of 6. The probability of 2, 4, and 6 is even, so there's 3 out of 6. The two events are not disjoint. Hint, not disjoint. Why? They both have 2 in them. So the total probability is not 5 out of 6, hence the word not. Total probability is 4 out of 6. Because there's 1, 2, 3, 4 different outcomes. That meet the criteria. 4 different outcomes that meet the criteria. 4 out of 6. Okay? For the formula, probability of E plus F, all the outcomes that are in both events are counted twice. Thus, to compute E or F, these outcomes must be subtracted once. So the general addition rule, key point here, general addition rule says probability of E or F is the probability of E plus the probability of F minus the probability of E and F. Remember, and means in both sets. Okay, and means both. This rule is true for disjoint events and for non-disjoint events. Wait, if they're disjoint, this would be 0. That makes sense. When choosing a card from a deck of cards, what is the probability of choosing a queen or a heart? Well, E is choosing a queen, F is choosing a heart. E and F are not disjoint because there is a queen of hearts. So we have to use the general addition rule. So the probability of a queen is 4 out of 52. The probability of a heart is 13 out of 52. And there's a queen of hearts. So 4 out of 52 plus 13 out of 52 minus 1 out of 52 leaves me 16 out of 52. Final answer. Okay, last thing on this section is the complement rule. Okay, the complement of an event, written E complement. Note E complement. Here it is. Okay, some do that. Others do this. E prime, same thing. All outcomes not in the event. So flipping a coin and getting heads, the complement is getting tails. Rolling a die and getting evens, the complement is getting odds. The weather is will rain, the complement is no, it won't. Okay? So the probability of a complement is 1 minus the probability of E. So it is obvious there's a 30% chance of rain, then there's 70% chance there is no rain. E and E complement are disjoint events and must add up to the entire sample space. So E plus E complement has to equal 1 or 100%. Okay, it either is in this group or it's not in this group. It can't be in both. Okay, the complement rule can be illustrated this way. If E is here, then the complement is the outside space. So if circle E is my event, then what is not in the event is in the sample space, which is the box. And that is a quick review of the notes for section 2. I will see you tomorrow.